Hi, everybody. Welcome back. We are talking about motor controls today, and I'm dusting off an old slideshow. And you'll look at it and say, man, that's a decrepit thing. But I actually love this one because you're going to see a lot of old school stuff. And so we're going to go through this one because it contains a lot of the old way of doing things. And once you understand the old way, understanding the new way and why things are the way that they are in the new way often becomes a little bit more apparent. So um, let's just go ahead and hit through this. Here's a review of some of the symbology around these things. You probably have seen this slide
Seen this in
before.
IMO, right?
And it shows you old school things where we had discrete components, like we had temperature switches and pressure switches. I mean, they're still around, but they're less prevalent because oftentimes now we're hooking these things up with analog signals and we're just generating those switching functions digitally, like inside the PLC. But a lot of these symbols are where a lot of PLC comes from. If you look at the contacts up there, the normally closed versus normally open contacts, that's what we see in PLC programming, right? So we're going to talk about a number of different types of components in this. We're going to talk about items that are sort of motor protection, like fuses and circuit breakers. We're going to talk about thermal overload relays, and we're going to talk about contactors. And we're going to show you lots of pictures of older school stuff, and it'll show you a little bit more about what is out there. So there are essentially two types that it's absolutely mandatory that you walk away from this program understanding how they work. And so those two things for old school manual wiring up of control for motors, you have 2-wire control and 3-wire control. 2-wire control, the control circuit is essentially just 2 wires.
Yep.
You've got it going through a float switch here, and that float switch determines whether or not that motor starter coil gets activated.
Energized. Yep.
And then it's also checking on the overload relay. So if we look at this, you can see that our that float switch that we see there, everything's in line. Everything needs to be on in order for it to work. The overload relay is a device that essentially thermally separates the contacts from each other when the load gets too hot. It actually physically kind of looks. Oh, kick my camera. It physically looks like what you see on the screen there, because those when those curls of metal heat up, they curl back on themselves tighter, and so that breaks the connection. And then when they cool off, they make contact again. So overload relays are just meant to make sure that we aren't sending too much current. Yeah.
Through the system.
Yeah, we don't. Those motor windings, like when you're first starting them up, they can generate, like they can draw a lot of current. If that motor stalls, it can generate a lot of current, and it can keep generating a lot of current because it's trying to spin. And so to protect those coils from melting in your motor and you having to huck out or rewind an entire motor, we want to have protection for it. Protection is key. And you can be a little bit like there's depending on the size of the motor, the bigger the motor is, the more you're going to want to protect it.
Yeah. The cost goes exponentially higher, and
Yeah.
the complexity of replacing it potentially could be also.
So you'll see overload relays used a lot. You will see fuses, circuit breakers. Depending on what you're talking about, you may see them in line, and we'll talk about that a little later on in this slideshow. But protecting your motor is an integral part of controlling your motor. So the 2-wire control is basically that you just have two wires going to whatever your conditions are for that motor to start. Now, that doesn't mean that you just have a float switch. It could mean that you have an enable switch that needs to be in the right position and a float switch. You can have any number of things. It's still two wires coming in and out of that. And if you look at this, the way that this will behave, the float switch comes on, the motor comes on. The float switch goes off, the motor goes off, right? So two-wire control is really good for those things that you want to be just controlled by a variable, and there's no, like, it's either on or it's off, and you're okay with that. But if you've got a push button, right, well, then it becomes a problem, right? So you'll see two-wire control a lot in automated things, like the float switch thing. This is sensing whether a level has dropped or a level has risen to the point where you need to pump the fluid out of that tank. And you just it automatically kicks on the motor, and so it pumps the water off until that float switch, goes down, and then it's going to.
Yeah, no different than the float valve in your toilet, right?
Yeah, right? No different than that.
Yeah.
So that is kind of the idea behind these things. They're things that you always want to do that. Now, there's a safety aspect to this too, right? Like, even if we were okay, or even if we just hooked a toggle switch rather than a push button switch onto a two-wire control, that does become a little dangerous, right? Let's say we hit the e-stop on our system, and we have a toggle switch that puts the motor in run. If we hit the e-stop, presumably we've got an emergency. If we reset that e-stop, it's going to go straight back into running. And that may cause another emergency, right? So there's a bit of a safety factor to this. If you lose power, right? If all of a sudden the power goes out in the building, your motor stops, and when you and then you're looking around for a flashlight and whatnot, and you're leaving stuff in strange places, it causes the chaos of that. What happens when the power comes back on? Well, that motor goes straight on. And so using this for things like saws and other forms of heavy machinery that can injure people, not a great idea. It's good for those background things like pumps and ventilation equipment and things like that, where if there's a certain circumstances are met, it's fine to run it. But things like saws, drills, heavy machinery of any kind, two-wire control isn't really going to cut it. But you might have two-wire control as a part of a more complex system, like maybe something that pumps the lubricant for a cutting machine or something like that. So for those cases, because of those safety concerns, in order to make things work, we have something called three-wire control, and you've probably already seen this on machines. It's where you have a start button, you have a stop button, and those are push buttons. And when you push the start button, it stays on after you let off of that push button, and that's because of the third wire involved here, because we are using on the contactor a contact from that. And that is giving us a signal as to whether or not the contactor has been made. And so we create an OR that is that is part of the line of control using the coil itself. So the normally open coil on that is going to be added to. Essentially, we wire that into our start and stop, so that if we press the start button and we have it is running, that contact becomes closed, and then it can be either that contact or the start button that keeps it going. So we can let off the start button and it will continue to go. Then if we hit the stop button, we break that circuit, the coil goes negative, and now there's two reasons why it's not working. So that means that if our power goes out, that coil is not active, so we would need a positive push of start at the beginning in order to make it happen.
Start.
So this, we're going to do examples of both 2 and 3 wire control on a motor in class in person. So you'll be able to get an idea of how this actually operates in person. But that's kind of the main differences between them. What do you like? What do you think? Is there stuff we should emphasize here?
No, I think you got it covered for the most part. I think a lot of the other stuff we'll cover in class. I think it'll be more impactful. I think when we do it in class.
Yeah.
Here you're kind of just staring at diagrams, going, "Oh, okay."
What am I even looking at?
Yeah.
But yeah, you can see some of these layouts. This diagram is actually a lot better for
Yeah.
showing that. This one even better.
Yeah, but still take a look at these. Try to make sense of them, and then once we get into class, they'll definitely
Yeah.
kind of.
And there's multiple ways in which you can achieve 3-wire control, and we'll show you a couple of different ways in class.
Yeah.
So it's worth spending a little bit of time kind of analyzing these, relating them back to, like, familiarize yourself with the symbology of these and know exactly what's going on here.
Yeah.
Come with questions on this so that we make sure that we handle that when we are doing this in person.
Yeah, and that is key. Research some of these. Just so you can get acquainted with some of the symbology here and understand them a little bit deeper.
Yeah. So apart from that, the real reason why I love this slide deck is all of the old components. And the thing is that old components work. You can still buy replacement contacts for all of these old school contactors. You can still buy replacement coils for them. They're really, like, extremely durable.
Yeah.
And so you will find these out there. And so it's important to, like, kind of recognize what they are, even if they look totally different because they're older. The tale on that is really often told of, like, how things work. So L1, L2, L3, that means it's 3-phase. Now, you can also have, you'll see, like, A, and you'll see NO and NC on there for the additional auxiliary contacts. On older ones, sometimes those auxiliary contacts are off to the side, like this one right here, where it's just using the mechanical component of, like, that transparent part that's slapped onto the side. That's a normally open and normally closed contact. That's just using the lever that's inside there. To have it actuate at the same time as it's closing L1 to T1, L2 to T2. By the way, L1, L2, and L3 indicate what side is towards our power supply, and T1 indicates, T2, T3 indicates what's going towards our motor or towards our load. And so you will often see components that are in series where the connection is from T1 to L1. And then on the bottom of that, you'll have T1 to L1 of a third component. Because you stack them up, you would never connect L1 to L1 on another component. You would stack them up in that frame of reference. So L is a designator of a direction. It is not a designation of this is a terminal that we hook up to something like it,
That's a
which
good
is
distinction
an
to have.
important distinction to maintain. This one's super old, right? But it's great. You can spend some time looking at all of the things that make up a contactor. So spend some time with this slide. Look at, like, this and I mean, geez, this looks like it's from the 50s.
Easy, yeah.
Or 40s, maybe.
Yeah.
You know.
And I mean, chances are you might run into something like this out in the world. I mean, there's factories. I recall being in the Port Townsend paper mill, and some of those pieces of equipment are in there from the 30s.
Yeah, absolutely.
And I mean, I was like, impressed.
Why replace it? We haven't built anything better on this.
No, and they still work, and minimal maintenance on those things. And why replace it? Because the cost of replacing it, and then the downtime involved with that, right? So you got to take all these. Like, you think, well, why wouldn't they just replace it? Well, time, money, right?
Time,
and
money,
production.
and like, you have to ask yourself every single time, like, what features of new stuff have actually been improvements.
Yeah,
And
yeah, right.
honestly, sometimes there's not very many
Yeah,
of them.
the fact that these things, some of these things have been in play for over 80 years and are still working at
Yeah.
the same facility. I mean, it just kind of tells you how, some of those things were built back. Not that everything was built great back in the day, but man, some of that stuff is still very, very stout and still working.
Yeah, I mean the main difference between what like a lot like the main advances that we've gotten in some areas like that don't involve like sophisticated electronics is that we've gotten closer at building things to tolerance, but by the same token that exact thing there means that we've also made them a little bit more fragile,
Yeah, more sensitive. Yeah.
more sensitive. Whereas the things back in the day, because
Oh,
they had to
man,
deal with such wide gaps of things,
They
are
can-
so over-engineered.
They're so robust and they can take a beating. I mean, literally.
Yeah, yeah. So here's an example of how you would see these in a control cabinet. You'll see the panel-mounted stuff on the front that are the controls, and so all of this wiring, you're not going to be able to tell just by looking at it whether it's 2-3 wire forward reverse
Right.
control,
No.
what the control circuit
You have
is.
to have a schematic.
You have to have a schematic. But this is really good wire organization for not having cable track in it.
Yeah.
So that's kind of
Yeah,
nice
those
there.
bends look really nice.
Yeah.
Yeah, and literally when I mentioned this earlier, is these cabinets will take a beating. I
Yeah.
mean, these contactors that are in there they jar the cabinet. I mean,
You'll hear them
you
like
hear the
you
thump.
hear the thunk as
Yeah.
those are closing. Yeah, absolutely. Absolutely. So here's some smaller, newer ones. They're not like as old as some of the older ones, but they're still relatively old. This is what they've looked like basically since the 90s.
forever, yeah. They'll still thump. They'll
They'll still thump.
Yeah.
It's still mechanically switching these things. Like contactors mechanically switch it. But in essence, it's really just a
Big
a
coil.
relay, a
Yeah.
big coil, and some contacts to it. So this is a worthy slide for you to spend a little time on and take a look at, kind of see what all of the components are that go into them. Some of them include things like spring returns. You'll have some cushioning involved in some of them, but a lot of times you really do want it to slam shut really quickly.
Yeah.
A lot of times there's actually spring loading involved in making sure they close as fast as possible, because the longer it takes for them to close, the more arcing you're going to have between the contacts, because when it gets super close, it's generating sparks
Yep.
there. And that's what eventually causes the contacts
Failure,
to
yeah.
fail, because you get corrosion with that arcing. Again, we're like, these pictures are for you to like give you some context, to get you some experience of what you might see out there in the field. This is pretty common. You'll see R and F on two contacts that are both wired essentially into the same thing. And oftentimes that is done so that you swap the legs so that the motor goes in reverse when one contactor's on and the other one is not. And you'll see some more of that later. This is an overload relay, and it's setting like that little potentiometer that we see there is setting what amperage it will shut off on. Sometimes overload relays have manual resets where you have to manually reset. It's not going to allow those contacts to come back into and some are self-resetting. And so there's various different flavors of overload relays.
Yeah.
Overload relays, super important.
Yeah. Typically, you're going to see the manual.
So, and it's important to understand, like, they're less prevalent now than they used to be. But that's because we've started using VFDs, and VFDs kind of have a built-in overload relay in them. So VFDs will do a lot of the work to protect a motor that we were otherwise doing with circuit breakers and fuses and overload relays, because each of those was protecting the motor from a very specific thing. Like, fuses are meant to handle like surges in voltage. Circuit breakers are meant to like protect the overall circuit and infrastructure around from an overcurrent situation, and then overload relays were meant to really stop it from damaging just the motor itself. A lot of times all three of these things are like, you'll still see these stacked on the outside, and they'll still be recommended to be stacked on the outside, but a lot of times, particularly on smaller motors, you don't necessarily need them. The VFD will handle a lot of these for you.
Yeah, and some of these, I mean, maybe at your house, you might be able to look at a cabinet that might have some of these components that we just mentioned, like for a septic pump.
Yeah.
You might go take a look at your panel and take a look at it. Don't mess with anything in there, but just go take a look at it, and that's what you're hearing when your septic pump comes on. Whatever time of night it comes on, you've set it. Once that float switch gets to a certain level, you hear that thump. And so if you want to kind of take a closer look, that's something that might be, if you have one at home, check it out.
So here we have some stacked protection. Here we have fuses up at the top. We have a circuit breaker in line with that, because those two, like, they kind of functionally do similar things, but fuses pop with higher voltage. Like it is current too, but like you can get them to pop fast. Whereas circuit breakers, it's almost entirely that, and you can reset them.
That's the big difference, right? We can reset the circuit breakers, but we can't reset a fuse.
Yeah.
Fuses, once it's gone, like
it's gone.
You got to replace it.
It's gone.
But that's what makes them so inexpensive as well. Is that
absolutely,
easy to replace. A breaker, a little bit different, a little bit more expensive, right?
Yeah, absolutely. Then here we start getting into some additional, like, old school wiring diagrams that are much less prevalent nowadays. Usually when you do these things, you're kind of wiring the start and the stop button as a home run to your PLC. And if you're going to have a second station, you're going to have that second station wired separately. But this, you can see how this is using the second station start and stop in parallel with the start and stop. And you can see that it latches it on using the M for the motor coil. So this is actually like a multiple start-stop stations in 3-wire control. And there's several different, just to give you an idea of different ways of visualizing it, and hopefully like comparing these as you go through these slides is what we really want you to do here. We want you to look at these schematics and analyze them and really kind of make sure you understand them. Having multiple different ways of laying that out helps you see it helps different people see different relationships. Typical other thing that you'll see is forward and reverse control. Again, all we need to do to reverse the direction of a 3-phase induction motor is just flip two of those.
As you can see in the diagram, they flipped around A and C.
Yeah.
So.
Yeah, you can flip any two of them, and it will change the direction. Funny story of humility. I learned about the flipping of 2 phases to change the direction of the motor from an old Sea Dog. And he told me, without really explaining it, but he said, if you flip phase 1 and phase 2, it'll work. And it'll go in the opposite direction. He told me, don't flip phase 2 and 3. And don't flip, for whatever you do, don't flip 1 and 3. And I took this as an article of faith for, I think, about 15 years. Until one of my students goes, well, wait, can't you just swap any 2? And I got a little dogmatic about it. I was like, oh.
Well, we hold on to that bone sometimes when you get those,
But you know what? The thing is that I took it as an article of faith. It worked every single time that I did it that way,
without fail. Yeah.
right, without fail. But it wasn't the only way that I could do it without fail. And that can blind you sometimes.
Yeah,
And so like pretty soon I'm drawing out the phases on the board and I'm like thinking about the windings of the motor, and then sure enough, no, it's any two.
Yeah.
And they do, and I'd been talking about it wrong. Like the thing was that I wasn't teaching anybody something that wouldn't work.
That wasn't. Yeah, it was incorrect. Right.
But I was teaching them the wrong thing because it didn't include all applications.
I mean, I guess that kind of implies that we're getting old, because what's the old saying? You get stuck in your ways, huh?
You get stuck in your ways, yeah.
I guess we are old. That's fine.
Yep. But the forward reverse circuits that you see here are all going to do that sort of thing where you flip two of the legs. And it's really just hooking them up to different legs in different circumstances, whether the forward contactor is on or the reverse contactor is on. And there's many different ways of doing that. And you can kind of look at these here to kind of get an array of how one would lay that out. So there's multiple schematics for you to look at. And then you'll see these where you'll see two contactors that are essentially wired in parallel with one another, and then their output is put together into, say, the overload relay or straight into the motor. And so basically, whichever one is active, whichever contact is active, is going to be the phases that are going to be sent to it. Oftentimes, they're tied together with interlocks that like physically don't allow one to actuate when the other one is activated.
Yeah, it's quite common.
Yeah, quite common to have like mechanical interlocks between a forward and
Definitely don't want
reverse.
those both on at the same
Because
time.
if you send them both at the same time, you were sending some weird
Yeah.
stuff to the motor. You're sending two phases to the same windings, and yowza.
Yeah, which I'm sure happened at some point, or else these interlocks probably wouldn't exist, right?
Yeah, yeah, and like
At some point.
the thing is, I actually I don't think I know what would happen if I sent two phases to the same.
And we're not going to try it.
And we're not going to try it. Like somebody figured that out long ago, and they
Yeah.
put mechanical locks to make sure I never had to learn that.
Yeah, this is where we don't ask questions.
This is where we don't ask questions. Whatever it is, it's bad. I'm sure.
Yeah.
It's don't cross the streams. Don't cross the streams.
Hey, fitting for Halloween.
Yeah.
There you go.
So yeah, again, you'll see multiple versions of sort of forward reverse things. It is quite often that you will see like because these components don't say forward and reverse on them, you'll often see things like I'm just
Right there, you can see.
right here. You can see just scrawled on there F and R
Yeah.
to make it transparent in there. A lot of other scratching and scrawling going on in there. But yeah, like here they're just sharpied on there, forward and reverse. And all these pictures, they're not meant to be anything more than just to kind of show you the broad array
what you
of
see
what
out
you
there.
see out there in cabinets. Yeah, just
So you don't have to hand draw it. You can make a label and put it on.
you can make a label and put it on there. Yeah, you don't have to scroll on it. If you scroll on it, make sure it's legible.
Yeah.
I don't want to be asking whether that's a 4 or an
Yeah.
R, right? Make sure it's legible. Otherwise, use a label maker. Yeah, these are scrawled on as well. So you see that an awful lot. Like it's not uncommon. And a few more schematics for you to look at. These ones will challenge you. Really, like these are good ones to really kind of spend some time like figuring out exactly what's going on in them, because it's exercising your schematic reading abilities. It's really going to help you improve that skill. So please spend some time with these slides, even though we're not here in the video. I think that's best done on your own, and that's why we're going to provide you with the PowerPoint slides for this. Push button jogging. So this is where you're jogging a motor. So you basically have it. You have an enable, which is the run part of it, but then the jogging is something you're toggling back and forth between having it on or having it off, which is typical for any sort of linear motion machines. You're going to want to have the ability for it to jog in one direction and jog in the other. So you'd have jogging combined with a forward and reverse control circuit. So you can get these and then combine them with some of the circuits that you had before. So don't look at these as things in a vacuum. These can work combinatorially, you know, and these are just kind of like Lego blocks that we use time and time again out there. Control relay jogging. So control relays are something that we will actually use in PLC programming, but they used to be used in actual like physical machine wiring. Less so now. It's actually pretty rare to have control relays that are physical relays anymore. They're usually in a PLC programming.
Yeah.
But you might find one out there.
Maybe.
You might. Yeah. So yeah, here this is forward, reverse. So this is the total combination set here. Forward, reverse, control, relay jogging. And so you can kind of see how like these things are combined together. That's all we've really got for you here. I think it's really important that you spend a little bit of time going through the slides and really trying to understand what's happening on all of those schematics.
Yeah.
Familiarizing yourself, you know, like relate that, like look and see if you can relate to one of the schematics what you see in some of the pictures of how those components are actually wired up.
That's good.
Because those are like those are good exercises to get you additional practice on schematic reading and wiring competencies. There's a lot that you can gain from this old school way of looking at things, and I like partially you're going to need it because the old stuff doesn't break and it still hangs around, and it's going to continue to
Still
hang
gonna need to
around
work with it.
until it blows up or burns in a fire.
Yeah. Yeah, very true.
So
I mean, when you think about it, like you think all the old Boeing systems they've had there for making planes, right?
Oh, yeah.
A lot of those have been retrofitted with current systems, but still,
Oh, yeah.
they're a combination of the old world now with the new, and so whether you like it or not, you're going to have to play with these at some point.
you know, like I have gone and I know that other programs on campus, you know, back when Boeing surplus used to be a thing in like the early 2000s, you could go into Boeing surplus and they were just surplusing a lathe from the 20s, right? Like from the 20s. So we're talking about the better part of a century. This was a tool that was active. And it's like you're going to find these things out there. It's important that you know how to deal with them. And understanding how you deal with the old stuff will actually help you with the new stuff. So
Yeah,
there you have it.
very true. Cool.
All right. Well, I guess we'll see you in the next video.
All right. See you next time.